At this time, it gives me more pleasure to introduce to you Dr. Debapriya Chakrabarti, who has joined us. And I would like to invite him to talk to us more about modeling, about the pitfalls, and you can address these questions which we have been discussing. Thank you, Dr. Debapriya, for joining us. All yours.
Perfect. Thank you very much. So I'll just make a quick, small discussion about three interrelated things. Number one is to deal with categorical variable, uh, which I'll be talking about a bit with this question, like why is it important to fix a baseline predictor variable? This question you would understand if you have gone through my presentation that I have shared already, that in logistic regression, you can have multiple predictor variables that are categorical. And when you look at the results, one of them is not there. It's just dropped. Why is that the case? And so it's dropped because it has been fixed. And why is it necessary to fix? Um, and finally, I mean, the way I have organized this thing to also give a broader general idea about how to deal with a statistical problem, about models, about modeling. See, as Ashish, you told me about the background of most of the audience, the participants, that they are not statisticians, but they are practicing scientists, biomedical scientists, and they want to interest and they want to learn, practice practical issues with statistics and how to do it. I am also the similar thing. I myself come from epidemiological genetics background, and now I study viral epidemics. So I use genetic data to track viruses. And I use a lot of statistical tools, and my statistical tools are actually come later. First comes the problem, the background, the backstory. And on the basis of that backstory, whatever tools I need, I get it from statistics. And that would be my suggestion to the audience, that most important thing is the backstory, the actual problem. One needs to first understand that, and based on that, one need to select the tool, statistical tool is required. And in that context, at the end of this presentation, I'll also share a small video, which is about how not to talk to a statistician. But that will come at the end. So first, let's think about why is it important for a logistical regression to fix a baseline predictor. Uh, well, there are two reasons. One of them is practical, and one of them is a theoretical one. Here, I'll focus on the practical reason, and I'll show you in practice how to address this problem. So as I said, let's first consider a biological problem. Yes, so this is the story. So this is, we have urban areas in many countries now, in particularly in developing countries. And then one of the questions that came up is that the self-medication rate, do patients tend to self-medicate a lot? And the hypothesis was, when people are looking at urban population, the question was that, is it that the migrants who tend to come from the rural areas into the urban areas, do they actually tend to self-medicate more than the locals which could be urban or rural for a particular state? Uh, and of course, the idea is that possibly is that because the people who are coming from rural areas, they are less educated and blah, 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 like a lot of other things. But the main question is, do migrants tend to self-medicate more than the locals? And so if you just plot it in it's like a model, you already know that the self-medication in this case is the response variable or the dependent variable, and then you have the predictor variables like migrants plus locals, right? So we want to see how these two things are related, these two sides. So we need to get some data, and there is a lot of data available from China. This study actually has been done in China, And if you get to the data, you will see something like what you see in your screen. So you have like different rows, multiple rows. This is of course a small part of the huge data set. And you have multiple rows, which is coded is 0, 0, 0 means no, they don't self-medicate, 1 means they self-medicate, and then you have local and migrant further divided into. So how they collect the data is that they will go to households, and in this household they will ask, so are you originally from this place, or did you come from another place? Which place did you come from? The place they come from, is it a rural or urban, like that. So rural out means migrants that came from some rural area outside the state or province. Urban out means migrants who came from some other urban areas into this state. Then you have the rural in, that the respondents who are from a rural part of this of the state where the study was taken. And then I'm sorry, this is a there is a typo. So one would be rural in, urban out, and urban in. No, no, rural out, urban out, rural in, urban in. The last one should be urban in, but I put rural out. So essentially four groups. So two groups of migrants who came from outside. Did they come from rural area or urban area? And two groups of local people who are either from rural area or urban area. So the details are not important. This is just for example, just to take an overall idea about the self-medication, the data. This is real data result, and overall across all groups of respondents, what you find is generally there are fewer people who tend to self-medicate in that one. Just for the sake of just to show you how the data look like. So if you just plot all the different predictor variables, what you see is generally most of the Chinese provinces, like there are a few provinces that the data has been collected from, is more or less is rural or urban divide. Only there are few provinces like Shanghai, which is a big province, or Guangdong or Zhejiang, where you have the local population as well as the significant large number of migrant populations who are might be from urban or rural. So this is the data. Now let's do the logistic regression, and let's see how that looks like. So if you just fit, and I'll be doing this in R, uh, which is nothing special than like Stata or SAS. Is just you need to put a command line, and you need to know everything details. But ultimately, if you just put some certain commands and you get these coefficients, and what you see is from the outcomes, we can only see three types, right? Rural out, urban in, urban out. This is what I was talking of talking about earlier, is that there is one variable is dropped. You can do it in any other software. This will be the similar outcome that you will get, similar. This is because the system automatically choose one category as the baseline to compare with the other category. So in effect, uh, what you see here is the rural in, that is the local people from the rural part of the province, is automatically chosen as a baseline. And you would not know this until you know that in R, this baseline categorical variable is chosen based on alphabetical order. So rural in has I comes first after rural. So it has been alphabetically chosen, and they just dropped it and then compared all the other three predictor variables in comparison to that variable. So if you have to read this result, it would be something like this, that the regression can be interpreted as comparing with rural in, that local rural people, rural out increases the chance of taking self-medication by 0.507. So the focus is on rural local, and the p-value refers to the significance of the outcomes. Now, all this is fine. So, but remember that the focus of the study is not really the local rural people, but we want to understand how the migrants behave about self medication, right? So the focus is the people who are coming from outside, and we would like to know if their behavior is significantly different from local people or not. So we need to focus on the rural out, or the people from the village areas from outside the province who are coming in, and then need to compare the others on the basis of that one, right? So the solution to this problem, but if you don't know about this situation, you would not know that actually what your result mean based on your biological, the scientific question. So you need to fix rural, sorry, the out, the migrant as the the baseline variable, and the solution is very simple in R. I'm sure it's also very simple in any other software, where you just adjust the baseline category to rural underscore out, so that the rest types can be compared respectively. And just with a couple of commands, you can do that quickly, and you get a new result. Now, if you look at the result, now the rural underscore out category is hidden from the model outcomes, because now we have fixed it as a baseline, right? And now on the basis of that, you can read the result, and you can interpret this model as comparing to the rural out type, that is the migrants from the villages, rural in decreases the chance because it's negative, the coefficient, the estimated, and chance of taking self-medication by 0.507. Urban in, that is the local urban people, decreases the chance of taking self-medication by 0.221, and the migrant from urban areas decreases the chance of taking self-medication by 0.495. So overall, what we can say is that we can therefore able to conclude that in this data set, compared with other people, non-local rural to urban migrant workers are more likely to take self-medication. But this is very important to understand, that if we would not know this trick about actually fixing which variable, which categorical variable, this result would not mean any biological sense. And this is a common problem that many people who are by training not statisticians, they face, and they find it difficult to um, address, uh, which is, I think, commonly called as something like a dummy variable trap. Anyway, this presentation that I made, I used a data and a post from this source. So if you guys are interested to know more details and how exactly the data look like, you can go there and uh, like play with it by yourself. Uh, as what I was talking about is the dummy variable trap. It's called a dummy variable trap. And some of you, if you are interested in the theory behind it, uh, just to pick your interest, you can go and explore this more. So this is a special case of something called perfect multi-collinearity of predictor variables. There's a lot of material available online. You can look it up and find out for yourself. Um, so that is, I think, that one of the biggest problems that people face with logistic regression models when they try to do with it. Um, Finally, you'll see the small YouTube video at your time, and you'll see how not to talk to statistician. And this is a problem which Ashish was talking about, like more general idea about models, how to deal with them, uh, how to decide which model to use for your data. This is a funny video, and but it sends the message across very perfectly. One of the things I face often with my other friends who come from more biology background, and we tend to often focus on the tool rather than what we want to do. As in English, they say if you have a hammer, you tend to see all the problems as nails. I think myself as a carpenter. So, and the hammers and the chisel and all the other tools are the statistical models that I use. But my interest as a biologist is not really the tools. I am not really interested in the tools, but I'm more interested in the wood and the furniture I would like to make. And in that context, the wood would be the data, the furniture would be the conclusion that I want to test, the hypothesis that I would like to test. And based on the wood and the furniture that I would like to make, I'll select my statistical tools. This is in general a very useful approach, and it can be adapted to many different problems. So you would not be fixed to certain kind of tools. This is a fantastic workshop that Ashish and his colleagues are organizing, but in few days you can only learn only a few tools. It's not possible to learn everything, and it's not necessary also, in my opinion. So first of all, focus more on the biology of the problem or the science of the problem, and then decide what you want to do with that. And based on that, you use a particular model. Very important, I think the second thing which I learned over the years is that be careful about collinearity, for example, what you guys are discussing. And often people have a tendency, particularly nowadays, because like software, computer is very easy to run really complex and big models. And this is the age of big data. And people just tend to quickly put together whatever data they could get their hands on. Doesn't matter what are the variables, what are the predictors. It's not very expensive to run a model, so they pile together all the different predictors and run a quickly model. I would strongly advise against it. Again, what would be the model should come from the biology of the problem. Just because its computational power is cheap, it's not advisable to just put everything together and test which one sticks to the hypothesis. There are multiple problems with that, which is not a, I mean, we don't have a time for this detailed discussion, but briefly, as a statistician or a biologist, the model should make sense biologically first. The computer, for example, should not tell you out of the different uh, predictor variables that you are testing which is the most likely. Or there should, I don't know if you guys deal with something called model selection. If you do model selection, I personally prefer that if it is possible, the biologist should select the model based on biological knowledge. We should not something called dredging, model dredging. We should not just because you have a lot of computational power have like 30, 40 variables. And so if in combinations, you can have thousands of model and then the software telling you which is the most likely model. No, I don't like that method of finding model selection. So essentially the bottom line is uh, that whatever we do, it should be anchored in biology. It should be anchored in the actual question. And the statistics, the statistical models will come later. This sounds like a very simple and a very uneasily understandable philosophy, but trust me, it's not that simple. The way we are often trained to first notice the tool and then based on the tool to decide what we want to do. This is not actually how science should be done, but I'll stop here now. And yeah, so those are the my two pences.
Thank you, Devapriyo. So the important take home message from that is that we have two approaches at handling confounding. One is what we call a theory or a science based approach, and that is called a literature based approach. And the other is the
I
data
see.
based approach. So, data based approach is what is model dredging, or when you have everything in front of you, you choose in a univariate analysis which one is significant and which one is not, and then try and put everything that was statistically significant into the model, although it may not make any sense biologically or by reviewing literature. Whereas the other, or the literature based approach, says that you understand the science and the biology behind the association before you build the model, and put only those variables which are biologically significant and make more common sense than trying to put only variables which make statistical significance. Thank you, Devapriyo,
Thank you very
for
much. Very
that
succinctly
quick
put.
emphasis.
Thank you.
Thank you. Um, At this time, let me call upon Dr. Amir once again, and you could lead the do it yourself exercise here. Amir.
So now we move ahead in the this logistic regression, and in this logistic regression, I have shared an Excel sheet with you all, in which there are various variables, and one variable is the internet addiction status, IA status. It is labeled as that, the name of the variable. So you can run the analysis and see what are you getting. So we have time right now. So we will give you 5 minutes, 5 minutes, 7 minutes, and just try it out. What are you getting? The outcome variable, what is the dependent variable, and what are the independent variables? And around 101 values are there, records are there in that Excel sheet. So at this time, I would request you all to run that analysis and see what are you getting. What steps did you do to find out conduct the regression, logistic regression?
Yeah, so the first time I did this, I imported the Excel sheet, and I actually opened the Excel sheet and looked at the data
Mm-hmm.
before I did anything else.
Mm-hmm.
And the way the outcome variable, the IA status, the internet addiction status was coded,
Mm-hmm.
it was coded as 1 if internet addiction was present,
Mm-hmm.
and 2 if it was not present. But
Yes.
for logistic regression, it has to be coded as 1 and 0. 1 if the outcome is present. So that was coded correctly. But the 2 had to be replaced by zeros.
Yes.
So I ran a replace command in status to replace the IA status with 0 if it was actually coded 2. I did that first. Then among the predictor variables, it looked like age, gender, and the course year would be important predictor variables. The other two looked like they were more like how you measured the outcome. So import, and we'll import the Excel spreadsheet, and I have it in my downloads folder. So there, this particular file, and I'll import the first row as variable names with lowercase, and okay, and I say yes. So it's been imported, and on the right side I can see the variables. They haven't been labeled, so but it looks like the first one is the serial number, the second one is age, gender, the uh, course year, then the stress summary maybe, or the score for stress, and the score for internet addiction maybe, and the finally the internet addiction status. And there is a description of the internet addiction status in this variable called h. I can also look at it here instead of looking at it in Excel. So I'm opening the data browser here. Yes, so I can see here that H actually explains the coding. So 2 is internet addiction absent and 1 is internet addiction present. So this 2 needs to be coded as 0 to run the logistic regression analysis. So I'll close the browser, the data browser, and the command to replace the numbers would be the replace command in Stata. So I'll type replace. Before that, I'd like to see what the I actually would like to tabulate the IA status uh, just to see what percentage actually had internet addiction. So it looks like about 27 were coded 1, and the remaining 74 we need to convert to zeros. This also helps because after any replace, we should run the tab again to see if it correctly did the uh, replacing. So I'll now type the replace command. So I'm going to replace the IA status uh, with the value 0 if the current IA status value is equal to 1, no, sorry, 2. And I'll run this command and it says 74 real changes made, but just to be sure, I'll run the tabulate command again. So it looks like now we have 74 zeros and 27 ones. So that's what we were expecting. So now that we have this, we can run the logistic regression. So I'm going to directly look at the odds ratios. So I ran the logistic command directly, but I could do the logit first. So for that, if I wanted to see the beta coefficients, I could run logit IA status. So that is a dependent variable or the outcome variable. And then the predictors. So in this case, the serial number obviously should not be a predictor. So we were focused on age being a predictor, gender would be a categorical predictor, and the year of the course. But anyway, this year could also be a categorical predictor which needs to be handled differently. But for the time being, I'm running it as it is. So this is the output I get. I'll ignore the coefficients for the time being, but it looks like gender is a significant predictor, and the others aren't significant predictors of the outcome.
Thank you. Excellent, excellent, Dr. Nishad. So, Dr. Nishad has cleared this that the outcome variable has to be, when we're talking about binary logistic regression, in zeros and ones. And zero is no internet addiction or no disease status, or the outcome of interest is not present. And one present, when one should be, that is the disease status is present or internet addiction is present, or the outcome of interest is present in what is the outcome of interest in our study. So here in the outcome variable, the outcome of interest was the presence of internet addiction, and we want to know the presence of internet addiction as compared to those who don't have. So whether those who have internet addiction, how is the other are the other variables independent variables associated with that particular outcome of interest. So that is one thing. Another thing is about sample size. If you remember, we have not talked about sample size, about regression as such. We talked about case control, cohort, and all these things. For medical sciences, even though for logistic regression using the beta coefficients and other things, you have ways to calculate sample size. But a rule of thumb that we use for regression analysis sample size is that for the outcome of interest, how many outcome of interest you have. In this case, as Dr. Nishad showed, that around 27 were there with internet addiction. So if you have 27, so the number of independent variables that can go with it are around 3. So we say that around 10 values of outcome of interest for one independent variable. So if you have more independent variable, then you need to have more outcome of interest in your dependent variable. That is important. So that is one thing. Another thing is Dr. Nishad showed about the outcome variable, that 0 and 1. So 0 is the reference and 1 is that you want the outcome of interest is 1. What about the other part, that is the independent variable or the predictors or the covariates? Now there we have this particular, what we say, there we should have, for categorical variables we should have the reference value, as Dr. Debapriya was mentioning, that it is important to identify the reference value in your variable. So I will come back to Dr. Nishad. Can you fix the reference value in the independent variable? Did you try to do that?
No, I haven't done that, but we can fix the for the categorical variable, that is year of study. We can do that.
Yes.
Uh, so I think
So okay, thank you.
yeah.
I will keep that as a homework also. That do the logistic regression, because the interpretation of the output will be dependent on what is the reference value, both in outcome, that is a dependent variable, and all, that is the internet addiction in this case, and the predictor variables or the covariates, that is the age, gender, and other things that are there. So in both the cases, what are the reference values? Based on the reference values, we will uh, interpret the output when we will give statement that this particular gender is associated with internet addiction by this many times, and we say odds, or odds actually. So all these things will come out. It will depend upon the reference values that you have set in. I think I am not going to go into the interpretation of the output right now. Next, Dr. Shailja will be sharing with you about reporting in the journals, what the output reports show. And then we will have Mary with us, as Dr. Ashish has mentioned. And she will be speaking about the logistic regression, output and interpretation, and all these things. So I think it is better that we grasp that aspect there. And this will be one of the homework that you can fix in Stata, the reference values, and interpret the output that you get in this internet addiction data set.